If we graph the functions that we've just created tables for, the y equals x function, remember, what had points 0, 0, 1, 1, 2, 2, 3, 3. Every time we increase x by 1, y increases by 1. So this table has a uniform slope, it turns out, of 1. Every time we go over 1, we go up 1. And the graph is going to be a straight line. We call y equals x the straight line or linear function. So y equals x is our basic linear function. Y equals x squared is our basic parabola, and we've seen the graph of y equals x squared. Here's a rather poorly drawn graph. I didn't use a very consistent scale here. And this point's really out too far. It's a little lopsided in that direction. But you still get the idea. There's our parabola. That parabola is going to give rise to the family of quadratic functions. Y equals 2 to the x is an exponential. Because x is in the exponent, we call this an exponential function. And we're going to take this as our basic exponential function. Some people take y equals e to the x to be the basic exponential function, and there's nothing at all wrong with that, but 2 to the x is more immediately understandable at this level. We don't have to go through a big explanation of what e is. For information, e turns out to be a number between 2 and 3, a little bit closer to 3. Now the graph of y equals 2 to the x looks like this. Recall that at negative 3, our y coordinate was 1/8. So instead of coming up 1, we only come up 1/8 here. At negative 2, it's 1/4. At negative 1, it's 1/2. At 0, it's 1, and so forth. Doubling each time. Each time we move over 1, we double the value of y equals 2 to the x. As we come down along the exponential toward the y-axis, we see that toward the t-axis, or the x-axis in this case, we see that the graph gets closer and closer to the x-axis. Every time we move over 1 unit, it gets half as big. So it's always moving twice as close to the x-axis. Here it's 1 unit, 1/2 unit, 1/4 unit, 1/8 of a unit. It's going to continue moving closer and closer to the x-axis, but never touch it. When a graph approaches a line the way this graph approaches the x-axis, getting closer and closer, as close as we wish, closer than any number we can think of, but never quite touching, we call that line an asymptote. So we say that the x-axis is an asymptote for our basic y equals 2 to the x function. So we have 3 basic kinds of graphs here. Okay, we can give them names. We have parabolas. Parabolas have the characteristic that they're symmetric about their axis, an axis of symmetry. They have vertices. Every parabola has a vertex on its axis of symmetry, a high or low point. Exponentials are not symmetric. We saw the exponential function is not symmetric, but it does have an asymptote. And linear functions, as we've seen, give us straight lines, which is why we call them linear